Hi, my name is Christy Shedden. I teach 3rd, 4th, and 5th grade computer science at Farragut Intermediate School. I'm so glad you decided to join me today. This is Activity 3, Science, for 2nd grade. The handout that accompanies this video can be found at the Knox County School website underneath the Student Resource tab. Today, we're going to be learning about friction. If this video is hard to understand, here are some options to help you. Number 1, turn on closed captions if available. Number 2, adjust the playback speed to slow down the video. Number 3, consider watching short clips, then pause, listen, and watch again. And number 4, ask someone in your home to watch the video with you. Stop it frequently and talk to your partner about what you heard and understand. We're going to be learning Standard 2, Physical Science. Students will make observations and conduct experiments to provide evidence that friction produces heat and reduces or increases the motion of an object. Let's get started. Have you ever rubbed your hands together? Let's try it. Rub your hands together as fast as you can for 10 seconds. Ready, set, go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, stop. Now, touch your hands to your cheeks. What do you observe about your hands? Yes, they're warmer. When would be a good time that rubbing your hands together would be useful? Maybe on a cold winter's day, if I forgot my gloves or mittens, I could rub my hands together to warm them up. When two objects slide against each other, friction between the objects causes heat to be produced. In this experiment, the two objects are your two hands. When you rub them together, you are using the force of friction, and that creates heat, which warms your hands up. What are some other examples of heat caused by friction? Have you ever gotten a blister from doing the monkey bars before? That's caused by friction. My hands are one object, and the monkey bars are the other object. If I do the monkey bars for a long time, my hand rubs against the metal of the monkey bars. With the force of friction, the heat causes the blisters. Another example is tug of war. Have you ever played tug of war before? I have, and my hands have gotten red and hot. Why? Friction. My hands are one object, and the rope is the other. My hands rub against the rope. Friction, causing the heat that makes my hands red. These are a couple examples of friction with my hands. What about my feet? Have you ever worn shoes that were too big or too small? I have. And what happened at the end of the day? I had a blister on my toe or my heel. Yes, that's friction too. In this case, the shoe is one object and my foot is the other. As the shoe rubs back and forth on my foot throughout the day, friction causes the heat and the heat results in a blister. How about some other options that don't sound painful? Here's one. The baseball player trying to slide into home base before he's called out. In this case, the two objects are 1, the baseball player, and 2, the ground. The baseball player is rubbing against the ground, and he might get some stains on his uniform, or his knees, belly, hands, or elbows might get a little hot from the friction of sliding home. So what do these examples teach us? Friction is a force that produces heat by having two objects rubbing against each other. Now it's activity time. We are going to measure the distance a toy travels on our pretend roads. The goal is to understand that the roughness or smoothness of the surface impacts how much friction there will be applied to a toy. Let's predict. Do you think the toy will travel farther on the surface that is rough or smooth? Remember, a prediction is a good guess based on the information we have. You're going to need some materials for this activity. I had pizza last night for dinner, so I'm going to use my pizza box. Some other options might be a clipboard, a piece of cardboard, a piece of wood, or even a board game box. You're going to need a ramp height. This will elevate your ramp. Choose 2 or 3 items of similar height. Example, 3 blocks or 3 books. You will also need a measuring tool. You only need one. Choose a ruler, a tape measure, a piece of paper or tape marked at equal distances. You can look at my picture for an example. Then we're going to need 2 types of roads. Now these are pretend roads, friends. Please do not go in the real road for this activity. Choose one smooth surface. This could be a wood floor, a tile floor, or a sidewalk. Then choose a rough surface, like carpet, a rug, a towel, some felt or foam, or even the grass outside. Last, you're going to need a toy that rolls down the ramp. This could be a toy car or a small ball. Other options might be a large button or even a spool of thread. Now that you have your materials together, let's get started. Step 1 of the planning process. Choose a place to set up your ramp that will have a level, smooth surface. Remember, this can be a hard floor, the sidewalk, or tile. Place your blocks or books under one end of your ramp. Your ramp should look like the picture in your handout. Make sure you have enough space. Step 2, lay your measuring tool on the surface at the bottom of the ramp. Place a measuring tool starting with 1 next to the end of your ramp. If you are using a piece of tape or paper, then mark it using equal distances. In the first picture, you can see that I did this using my index finger. I drew a line next to my finger and then scooted it down next to that line and continued until I got to the end of my piece of tape. In the second picture, you can see that I labeled each space starting with number 1 next to the ramp's edge. Step 3. Draw your ramp design in the box on your handout. Don't forget to label the materials. Let's go back to our prediction. Which of the road materials will cause the car to roll the farthest? Do you think the rough surface or the smooth surface will cause your car to roll the farthest? Let's find out. Step 4. Place a toy at the top of the ramp and let it go. Don't touch the toy until it stops rolling. A helpful hint is to try and aim your toy so it rolls straight. Ready, set, go! Wow, that went really far. Let's observe how far it went. Use your measuring tool to find out how far your toy rolled. In the picture, you can see that my car is not exactly next to my ruler. So I'm using my hand to try and draw a straight line from the front of my car over to the ruler. You could use a book or a piece of paper or a ruler or some other straight edge to do this. Now, let's record our data in the table on your handout. In this table, we have 3 columns. The first column is labeled Experiment. Remember, columns go up and down. In this column, I'm labeling whether this is my smooth road or my rough road. In the middle column is the road material. What did I use for my road? And in the third column, this is the distance. How far did our toy roll? Ready? See where my blue arrow is at? This is the row for the smooth road test 1. I used my wood floor, so I'm going to write wood underneath the road material. In the last column, I'm going to record 105 inches. That was really far. Now, I'm going to test it again. We're going to keep everything exactly the same and test it one more time. Record your data in the table again. This time, it's going to go in the row with the red arrow, where it says Smooth Road Test 2. Again, I used my wood floor, and this time it went 104 inches. You can see that the distance are pretty close together. Now, we're going to try the rough road test. Set up your ramp in a place with a rough surface. Remember, this could be grass or a carpeted area or even on a towel. Roll your toy down 2 times and record your data in the table on your handout, just like we did for the smooth road test. See where my yellow arrow is at? This is the row where I'm going to record this data. It says Rough Road Test 1. My road material this time is carpet, and the distance was 35 inches. I'm going to do it exactly the same again on the carpet. So where my green arrow is at, I'm going to record my data for my rough road test number 2. Here's the carpet, and this time it went 36 inches. You can see that the distance for both rough road test 1 and test 2 are pretty close also. Back to our prediction. Which of the road materials will cause the car to roll the farthest? If I go back to my table and look at my data, I can see that my smooth road test on the wood, the distances were further than on my rough road test on the carpet, which were less. Which of the road materials will cause the car to roll the farthest? You got it, the smooth surface. Let's look at this another way. Which material slowed your toy down the most? On which material did your toy go the least distance? You got it, the rough surface. Excellent. What is the name of the force that changed the distance your toy traveled?
Great job!
Friction. You got it. Now, a scientist isn't done when they're done with their first set of experiments. They like to reflect. So you are a scientist today. So let's reflect. What went well in your experiment today? Is there anything that you would change to try and make it better, to improve it? How would you improve your design to make the toy roll even farther? Would you change the height of your ramp by using more or less blocks or books? Would you use a different material for your road? Draw and label your improved design in the box below. Now, try it out. Did your changes improve your design? Yes or no? Sometimes when I try to change something to improve it, it doesn't work any better. So then I have to come up with a new idea. What other ideas do you have to improve your design? Thank you for joining me today. I would love to see your designs and your ideas. Please share those by tweeting at KCS Science. Thank you for joining me. Have a great day.